Okay, I'm back. Where was I? So we want to run the numbers when the boom's at 45 degrees, because without a counterweight, it's going to tip over. So I didn't draw a new poster. I just made the little changes on this one. So here's the boom. Now it's at 45 degrees instead of 60. We've got to find this distance. First we have to find this distance. Now the load is hanging down here now. So the imaginary line would be here. That's the distance we have to find. Now remember, with when it was at 60 degrees, the boom, or the hypotenuse, was twice as long as the distance, the short side. So we take the hypotenuse, or the boom, multiply by 0.5 to get the distance. With 45 degrees, same thing, but just a different number, 0.707. So here's a couple of 45, 45, 90 triangles. Take the boom, 16 times 0.707, that's what you get. 12 times 0.707, that's what you get. Take out your calculators and check, see if I'm right. So, this is 46 inches times 0.707, then this distance we get is 32.5 inches. Don't forget, we measure on this side of the fulcrum. So we got to subtract that 10 inches because this part is basically connected to the crane instead of to the load. So it's 22.5 inches, weight times distance. 22.5 inches times the load, which is 9.4 pounds, gives us 211.5. So the load is 211.5 inch-pounds. The crane itself is only 174. This is heavier than that, so it tips over. So what do we need to add to the weight of the crane to get the numbers to balance? So the difference between 211 and 174 is, come on, get out your calculators. I don't want to have to do all the work. I'm going to round it off to 40. It's a little less than 40, but let's call it 40 inch-pounds. So we have to add 40 inch-pounds to this number to equal that number. Then it'll balance. So we need 40 inch-pounds, not 40 inches or 40 pounds, but 40 inch-pounds. And where are we going to put the, first I'm going to lower the load so it doesn't tip over. So, weight times distance. The distance would be from the fulcrum to wherever we're going to put the load, the counterweight rather, which would probably be here. This would make most sense. And the distance from there to there is 40 inches. Very convenient. And these weigh 1 pound. 1 pound times 40 inches is 40 inch-pounds. So now, the torque on this side is the same as the torque on that side. So that means what? It balances. Is that a good idea? What if it's a windy day? That could happen. It balanced, but just barely. You don't want that to happen to your crane. So, maybe instead of just one clamp, we'll add another clamp, make it 2 clamps. Can you see what's happening here? It balances, but just takes either a windy day to make this move, or just a tiny bit of movement here and the whole thing tips over. So having everything perfectly balanced like in a seesaw is not a good idea. That's a little better. In the crane industry they have something called the safety factor, which is what we need here. Let's say all of this was 100 foot-pounds. and this is 100 foot-pounds, then it balances, but not very, it's not very safe. If this is 100 foot-pounds, we multiply by 1.5 and get 150 foot-pounds. That's the safety factor. So, how much more do we need over here to be safe? So well, that'll be the next video.